It is tempting to make our first game into a fun but complicated experience. Our goal, however, is to demonstrate the ability to weave rules into a pattern and then let that pattern turn into code. The more simple this endeavor is, the more focus can be centered on that main idea. To set this aim as the center of our work, I'm going to define 3 main goals. The first is to explore the earliest fundamental tools, namely comparing and deciding similarities and differences. The second is to see how programming languages are set up to handle these early tools. After all, a programming language is a formal way to describe patterns, so the most simple programming concepts in any language are likely to mirror the most simple tools that patterns abide by. The last goal is that a game is easy to explain and program. Complexity and extravagance will come later. Although there are 3 main goals, some side intentions are permissible. We want to balance the computer automating a multitude of steps with the simplicity of one event at a time. A simple solution to this is to allow the user to progress through the game loop manually. The game loop will perform any calculations it needs and then stop at a point and wait for user input. The user will answer a prompt and the loop continues with calculations and a prompt will reoccur. Automation is the main goal of our programs, the change of conscious activity into unconscious processes. The need to start simple is present. The automations should be limited to simple components, such as generation, computation, and comparison. A possible game that fulfills all of these requirements is a number comparison game. The program generates a number and displays it. The user enters a number of equivalent value. The program then compares the two, displays whether or not they are equal, and then repeats again from the beginning. This allows for exploration of computer-generating random info, holding onto info, comparing values, being interacted with while running, and some other basic programming concepts. At first, these rules have been described loosely in English. Now let's describe them in real time, unscripted, and as close to pseudocode as possible. That is, let's nail down the rules and patterns in as formal language as necessary. It doesn't need to be perfect, but the better we do, the easier it'll be to turn into code. Later, this pseudocode will serve as a base to quickly write a program in any desired language, where the only major concern will be technical issues and graphics, along with transcribing the pseudocode into the particular language that we're coding into. Hello. Alright, here we are on my desktop. We are going to be using this space as a live demonstration of me writing the pseudocode for our simple game. So there will be, most likely, mistakes. There will be pauses, awkward moments, but the whole point is that we are going to be kind of doing it together. You'll see what I'm doing, how I'm doing it. I'm going to cut it down to not take so much time, cut out any unnecessary bits. Hopefully you will still be able to follow along, but this is meant to be a lot more rough than the first half of this video. And I'm going to try this kind of format going forward with several videos and see if it works well for my purposes. As I am doing what I'm doing, however, I'm not just going to be doing it in a way that you watch. I will also try, when I can, as much as I can, to explain what I'm doing and why I'm doing it that way, so that the reasoning is preserved along with the product being developed in real time. So, let us start with a simple text document. We'll name this first game pseudo. The reason why I don't want to get too fancy yet. I'm sure there will be many tools that we will use in the future, but sometimes, especially at the beginning, a simplest tool works best. So let us create a little reminder of what our game is going to be. So this is just going to be the English version of our game. Here is our program in English, just basically writing down what it needs to do. Let's break each of these into more concrete steps, try to get the pattern down of what's actually going on here. The very first thing the computer is going to need to do is create a way to hold information about a number. We are using numbers in this game. Numbers have information inherently. They are each different from each other, and we need a way to hold on to that information, to contain it in some way. Many different things in the world have different kinds of information. So we need to hold information specifically about a number. And because numbers have to do with math and programming has to do with math, it all makes a lot of sense that numbers are going to be one of the things that pretty much every programming language is going to support. Let's call the way we hold the information about a number a container, a number container. Of course, there's more official definitions and terms, but right now we'll just call it a number container. We need to fill it with some random value. How a computer generates a random value and what randomness is, we'll leave for another time because that can get complicated, and I'm sure every programming language does it a little bit differently and there's different implications. That doesn't matter. It could be pre-chosen randomly by a person and just entered into the computer. All that matters is, for this program, is that it seems random enough. So any function that a programming language has to create a random number will work completely fine for this application. These two steps are basically the first English sentence broken down into pseudocode enough for us. We haven't picked a language yet. The way languages and different computer constructs do things that seem very basic are done very differently. So we're not going to worry about that because we haven't even picked a language yet, and we're kind of working in a way that allows us to go to any language. So displaying is a very weird thing in programming. Sometimes it's meant to be the simplest part you first learn, and sometimes it's actually rather complicated and you have to take a lot of things for granted when you do display anything. But we are just going to write it in a way that makes enough sense to hold on to the pattern of what displaying means. So for whatever our programming language is and our whatever we're programming to, there is going to be a form of output. Every programming application is going to have forms of input, forms of calculation, and forms of output. Every programming language will have most likely a common output method. So for whatever that is for our language, we are going to use it to display the value of the contained number. This might be text, it might be a light blinking, but we can be fairly certain that there'll be an output method and we can display the value of the number through some pattern. Again, from the experience I've had with programming languages, input is another complicated thing, so we're going to take some things with some grace here. First thing we need is a little prompt to let the user know that it is time for them to enter a number. We need a second container to hold the information that the user enters, so we'll have to create a way to hold that. Interesting to note here is that we're doing the same thing right here in step 1 as we're doing right here in step 3. That kind of makes me believe that we'll be doing the same thing in programming many times over. There'll be a lot of similar things, creating a way to hold information about something. These little patterns that are kind of revealed in this way, I think they hint, they're signposts to interesting things that will be either reoccurring, which you can see it already sort of has, and might be a venue for getting good at this particular thing, because if you're good at doing this, then that skill is used in more than one place, so it has a little bit more value. Another thing is that if we're doing this, that's a big part of what programming is, if it's happening multiple times, and as you work on larger programs, you'll see some things happen a lot more, depending on the type of program. Like if we might end up doing this 100 times, because we might need to hold a lot of different information about numbers. Next, after we've told the user they can enter a value, we have a way to hold the value that they enter. Now the user can input a numerical value to be held in that container. That pretty much wraps up step 3, that the user enters an equal number. We might be able to, as part of that prompt, let the user know that it should be an equal number. It doesn't have to be. Again, this is just, a rough sentence. It could just be that the user just enters any number and we'll do with it what we choose. Remember, we're trying to keep this as simple as possible, so that's entirely optional to prompt the user to enter an equal number or not. And another thing we can add here is some sort of confirmation that the user entered a number, so we can confirm the user entered a number. Next, we need the computer to compare the two numbers and output true or false. All of the comparing, though, is going to happen automatically. Like I said, we had some secondary goals, some side intentions, and we were balancing computer automation with simplicity and with a user kind of controlling the main